on problem number 6 now, so let's go ahead and get started with that. What formulas are we going to need? We're going to do some particle motion stuff. We need velocity, we need acceleration, we need blah blah, blah blah blah, blah 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 blah, blah blah.
Taxi!
Where are we meeting them?
I don't know, let's just follow them.
Damn it, we lost them. How will we find them now?
Well, if you can figure out an equation that tracks their motion, then we can meet them at the next left turn.
How will we figure that out?
I don't know, let's just use a GPS.
Fisher is moving at a velocity modeled by the cosine of pi over 6t in the interval 0 to 12. I will tell you when he will be turning left, and from this you can catch him. Blah, We need to find when cosine is equal to 0. On the unit circle, cosine is 0 at pi over 2 and 3 pi over 2. So, we can make pi over 6 equal to pi over 2 by multiplying it by 3. And we can make it equal to 3 pi over 2 by multiplying it by 9. Fisher will be moving to the left for values between t equals 3 and t equals 9.
Alright, we caught them. Let's go get Fisher so we can interrogate him.
I don't know.
You know the answer. Tell us or we'll kill your friend.
Don't touch him. What's the interval of the equation then?
0 to 6.
Well, the total distance means that you have to take the absolute value of the equation.
The equation is the cosine of pi over 6 times t.
So the equation of the total distance is the integral from 0 to 6 and the absolute value of v of t dt. And don't forget dt.
That equation will do. We need to get deeper into his deep. One Diet Coke, please. Hi, I'm Mr. Charles.
And I'm Mr. Fisher.
I was sent here to help you with part C. See, you are dreaming right now, and there are people trying to hurt you, so you need to try really hard to remember anything from the other parts of the question.
I don't believe you.
Look around you. Do you see anything strange? Do you believe me now?
I do. So what do I do now?
We need to find the acceleration in order to solve part C. Was the speed increasing, decreasing, or neither at time t equals 4?
Well, to find the acceleration at t equals 4, we need to start at the velocity of the equation. The velocity of the equation is cosine pi over 6t. And this will involve chain rule if we have to find the derivative of this equation. So first, we have to find the derivative of the outside, which is cosine. So the derivative of the cosine is then negative sine, but we have to include what's the inside. So therefore, it's negative sine pi over 6t. Now we have to find the derivative of the inside. The inside is pi over 6t. The derivative of that is pi over 6. So the equation for the acceleration must be negative pi over 6 times sine of pi over 6t. But now we have to plug in 4 to find the actual acceleration. When you plug in 4, we get negative pi over 6 sine pi over 6 times 4. And the total acceleration is then negative phi square root of 3 over 12 miles per hour squared.
So the acceleration of the car was negative?
Yes, but now you have to plug in 4 to v of t, and you would also get negative.
So the acceleration and velocity is both negative?
Yes, so when the velocity is negative and our acceleration is negative, then the car is increasing in speed.
Since they were both negative, then the car at time 4 was increasing speed?
Yes, that's correct. I remember now.
Good. You have to trust me from now on.
Why?
YOLO. We have to meet Eames to go deeper into your dream and answer part D. Only you know the answer. Bear with me.
We need to get to the safe.
The answer to part D is in the safe.
Well, how do I open it?
It's a 4-letter passcode. What are the letters that are most important to you?
Well, it's not HYUN.
Try calc.
It doesn't work.
Try the one that you least expect.
Love?
It's worth a try.
God darn it, it doesn't work. How do we answer part D?
Keep trying.
Yen? Wait, it works. What is this? It's not my size. But what does 49ers got to do with part D?
But the 49ers didn't even make it to the Super Bowl last year.
Maybe the answer is Mr. Hyun. We need to wake up to get to the answer. Give him the kick.
Oh, that's not the kick we're looking for.
Now it's time to do part D. We need to find the position of the particle at time 4.
Oh, I know how to do that.
Well, come on up and
To
show
find
the
the
class.
position, we take the integral of the velocity, and using the fundamental theorem of calculus, we will get the integral from 0 to 4 of v of t dt is equal to s of 4. Because we want to solve for s of 4, we will add s of 0 to both sides. Therefore, s of 4 is equal to s of 0 plus the integral from 0 to 4 of cosine of pi over 6t dt. It is given that s of 0 is equal to negative 2. So, s of 4 is equal to negative 2 plus the integral from 0 to 4 cosine of pi over 6t dt. When we take the antiderivative, it becomes s of 4 is equal to negative 2 plus 6 over pi sine of pi over 6 times t, which is equal to negative 2 plus 6 over pi times sine of 2/3 pi minus sine of 0. When we plug in 4 and 0 into the antiderivative, this is equal to negative 2 plus 6 times the square root of 3 over 2 pi, which simplifies to 3 times the square root of 3 over pi minus 2 units.
SpongeBob! The integral of 0 to 6.
I stopped.